What evil lurks in the depths of coronal holes? The smAsho knows. Welcome to the Daily Space Weather. I'm your host, Dan, aka smAsho Mash. Did you know that coronal holes constantly emit a stream of protons? Yeah, there's a stream of protons coming out of that coronal hole right there. Will it stay intact long enough to send them toward the Earth? You'll have to tune into our later videos to figure that out, as it's too soon to know. Let's take a closer look. That is a South Pole-oriented coronal hole, by the way. And coronal holes are very important in looking at solar cycle progression. We'll take a look into various different data sets today and tell you how they relate to other things. So here's the colorized magnetogram from the SDO as well. Sunspot 2860 has remained largely stable over the past 24 hours, similar to the sort of the field structure we saw yesterday. No other major sunspots. I think Sunspot 2859 has degraded quite a bit. There is an active region rising up here. We don't see any umbrae when we do show prep today. Here's another wavelength. This is 94 angstroms. And one of the reasons we use 94 angstroms is to view things like solar flares. So solar flares are great to view in 94 angstroms because it takes more images per minute rather, than the other wavelengths, save for 131 angstroms. It takes 10 images per minute instead of only 2. So you get 5 times the temporal resolution in 94 angstroms, also 131 angstroms. They're both ionized iron ultraviolet light emission spectra. And you can read about that on the SDO The Sun Now site. Great view there of Sunspot 2860. And we've got more of these coming up as well as toward the end of the video. Great imagery there of the largest sunspot of recent weeks. This is the other wavelength, also ionized iron. It takes 10 images per minute instead of only 2. So when you see solar flares, if you want to take really high-res imagery of the solar flare event, we recommend 94 and 131 angstroms. The 10.7 centimeter radial flux, which is a measurement of overall solar activity, has come up to 91. There is the 1-year chart of that from Solon.info. The black line here is the radial flux, and the red line is the sunspot number. By the way, we've got an interesting paper coming out soon about solar cycle progression. So here we are on the Space Weather Enthusiast dashboard, and we never saw the geomagnetic storm that was forecast. There is another geomagnetic storm forecast for late tomorrow, September 1st, the first day of a smAsh-tember to OMASH member. Yeah, our official website launch is tomorrow. Make sure you join us. We'll be putting out all kinds of content all day about that. Expecting a G2 class KP6 event on September 2nd, at least NOAA is. And I don't know what they're talking about. So not to get too critical here, but here is their Enlil spiral. And there's the coronal mass ejection that was forecast for yesterday, and we didn't see it. There was a signal, and there's some good news and bad news about it. And you can see this doesn't look like a KP6 event on their Enlil spiral, but that's the forecast. So here's the coronal mass ejection that must have been completely mismodeled, as it certainly did not cause that level of changes in the solar wind. We're not expecting this one to cause a KP6 either. I'm at a loss as to how these models are derived. We'll look into it at a later time. Brief look at global seismicity here. We did see a mid-6 magnitude quake here, at least initial reports. I think it was downgraded to a 6.3, but there it is. There's a location of it in the Kermadec Trench south of Tonga, northeast of New Zealand. And we'll just scroll up the list here at the USGS site. South Sandwich Islands region went back to a higher level of seismicity here, and we saw a downtick in volcanoes. We'll get to it on the next slide. So South Sandwich Island still seeing 5 magnitude quakes there. Vanuatu saw a 5.0. A bunch of quakes up the west coast of the U.S. there. Fiji saw a deep quake at over 600 kilometers depth. That 4.5 magnitude would have been like a 6 magnitude had that quake happen at the surface. Again, estimated depth there, 608 kilometers. The 6.3 at New Zealand, or north of New Zealand in the Kermadec Trench, happened at 2:52 Universal Time today, August 31st. And if we ever miss anything in our earthquake reports, which we do daily on the Daily Space Weather videos, just leave us a comment. Let us know. We appreciate critical comments as well as nice, friendly, happy comments. Here is our volcano discovery rundown. And again, there's been a volcanic downtick here, it looks like. Karimsky, though, is still producing Vulcanian-style activity. No report on the ash plume there. 3.5 kilometer altitude ash plume drifted west. No report on current flight levels. Subinosejima in the Ryukyu Islands exploding. 13,000-foot ash plume there. So that's a continued uptick at Subinosejima. Nevado del Ruiz exploding. 20,000-foot ash plume over Colombia. So that remains at a heightened level. Revenador exploding. 15,000-foot ash plume produced by that over Ecuador. Sabancaya exploding. 24,000-foot ash plume over Peru. Please don't pole vault the caldera. If you'd like to check out our merch links, you can find them at smashomash.com. Just click smAsho merch. And a quick blurb about the Smash team. It's spectacular. And it's going to be replacing Patreon. We expect to phase it out completely. Patreon, that is. We expect to phase Patreon out completely by October 1st. So please cancel your membership over at Patreon. We've got actually 4 levels at the Smash team. A bronze level, which is free, silver member, which is $2.99 a month, gold member, $9.99 a month, or paid up, which also gets you a free month and a free merch item. Continuing on, the GOES magnetometer. Oh, and by the way, the Smash Team site is spectacular. Here's a teaser. We're going to actually put out a teaser here and show you some of the pay-only material on today's Daily Space Weather. So this isn't going to be a normal thing, as a lot of these posts are for paid members only, but there's all kinds of analysis in here that nobody else gets to see because we can't do this for free. And that's your teaser. So checking out the GOES magnetometer, this tells us about the field strength surrounding Earth. That's why we look at it. Magnetic fields are pretty important to a lot of different things. They help us to model all kinds of stuff like the magnetohydrodynamics. They help us to determine all kinds of stuff that's going on around planet Earth. The magnetic environment's pretty important to monitor. It's being monitored by the GOES 16 and GOES 17. There's the 3-day chart of it. We're actually seeing pretty low levels of magnetism here. And that can be caused by various things. I won't get into the physics of that at the moment. Let's look at the top view ecliptic plane field plot, looking at the sun's produced heliospheric current sheet. And Earth is just about to, well, there might be a delay on that. So Earth is currently in a North Pole current sheet, folks, shown here in green. That's North Pole. And we're seeing some coming through the South Pole here. So it could be associated with that activity rising in the northeast. It's a little too early to tell at this juncture. But there's the latest frame. Keep in mind it's about 2 hours old. And if everything stays the same as it is now, I would expect Earth to be in a South Pole-oriented current sheet by tomorrow. Also expect some higher readings in the GOES magnetometer, but not a whole lot higher, just a little higher. Here's a line of sight plot for the same data. It's gathered from 51 ground-based magnetometers and magnetometers on stereo A and stereo B at Lagrange point 5 and 4 respectively. Here's a line of sight plot. And it looks like that blue line is a little bit indecisive there. It's now approaching the equator. We'll be keeping an eye on it. And when I say eye on, oh, well, the pun is intentional. Here's a coronal hole plot, and this is probably the most important data set here for the observation of the solar cycle progression. So this tells us how the at solar minimum polar-oriented coronal holes are migrating, which is what a solar cycle actually is, folks. During a solar cycle, the South Pole eventually migrates to the north, and the North Pole eventually migrates to the south. And we can watch this happen by viewing coronal holes and the magnetism therein. And you can see this large, well-defined coronal hole we showed at the beginning of the video is South Pole oriented and just reaching up to the equator. So we could see what's called a terminator event about to happen here, where the sun suddenly explodes into massive activity. And we did, about a week ago, 10 days ago, forecast the next 60 days are going to be high in coronal holes. So don't be surprised to see an uptick in coronal holes. It's the forecast. And you can see the high likelihood of solar flares here. We're looking at very high likelihood of major flares, especially as sunspot 2860 approaches the limit. Still highly magnetically complex. You can see there beta gamma class. And yeah, coronal mass ejection watch still in effect. Solar flare warning still in effect, as it seems like there's a bit of a calm before the storm sort of thing going on when it comes to solar flares. So we expect 2860 to produce some large flares yet before it sets on the southwestern limb. Next, let's look at global geomagnetism. This will tell you where things like aurora borealis are more likely to happen, and impacts of coronal hole wind streams and coronal mass ejections. Also, massive magnetic changes can cause an increase in the KP index. It's a measurement of global geomagnetism. It's currently only at 2. Calm conditions. Here's the X-ray flux. This is showing us photons, and these are solar flares, folks. When we say solar flares, we mean photons, which is in the form of X-rays here. We're talking about high-frequency ionizing radiation. X-rays. You know, everybody knows what an X-ray is. You do it when you got a fractured bone. Please don't get a fractured bone. It kind of sucks. Anyway, you can see very low levels of X-ray flux here, and we're expecting an uptick promptly from sunspot 2860 especially. No spikes in the proton flux. This tells us when relativistic particles have made it all the way to the GOES 16. None have, as no coronal mass ejections have been particularly earthly in their trajectory. Next, we'll look at the real-time solar wind and show you the most tiny and nearly irrelevant coronal mass ejection we've possibly ever seen. Here it is, folks. Here's what NOAA forecasted would get to a geomagnetic storm condition. These little tiny spikes here, where it barely gets over 10 protons per cubic centimeter, and these little tiny downticks in the solar wind, and these little tiny temperature signals in the plasma temperature are all that we see from that largely missing coronal mass ejection. Will the next one produce an even stronger geomagnetism? I would say definitely not. I highly doubt it. And anyway, there's the current data on the real-time solar wind. Current conditions are 7.42 protons per cubic centimeter. For the density, solar wind speed 382 kilometers per second. Just nominal levels here, and steady stats over the past 12 hours. Looking at the geospace, this tells us what the space weather modeling framework calculates to be the magnetohydrodynamic pressure likely to be around planet Earth. It's 4 hours of data, and you can see it is quite consistent here over the past 4 hours. We show it daily anyway to help immerse our viewers in the data to get them to understand the relationship between different factors. Next, looking at ground magnetic perturbations here, measuring the Earth's magnetic, or modeling the Earth's magnetic field on the ground level in nanotesla. The last one was nanopascals. That's magnetohydrodynamic pressure. This is magnetic flux density. And geospace delta B is changes to Earth's B field. And we do see some magnetic perturbations here in the southern Indian Ocean. Nothing too exciting. And if you weren't aware, there's a polar excursion going on. Earth's south geomagnetic pole is someplace down here. North geomagnetic pole is someplace up here and a little on the weak side. Continuing on, here's a diagram of the solar system. If you're wondering where stuff's located, there's where it is currently. And we're going to advance this 1 week into a smAsho. It's going to be a smAsho to MASH member. And here's where things will be in a week. And there's your new moon anticipated for September 7th. Next, we put up a star chart here to show folks what's going on above my head. If you want to make a star chart for yourself, head to in-the-sky.org. Ours includes the galactic plane and the ecliptic plane. And the moon's near the apex of its passage across that ecliptic plane at the moment. Today's cosmology segment's going to have to be postponed. We've got too much stuff to do in preparation for tomorrow's smAsho kickoff. Next, charging hazards. Electrons surrounding planet Earth can charge up satellites. The low-energy electrons produce surface charging. The relativistic electrons produce internal charging. We do have minor surface charging and internal charging. And the reason you see these in different spots is because the electrons are traveling in different directions at the day-night terminator, and they're just flowing in opposite directions, and I won't get into that too in depth. It is the daily space weather after all, but we do see some relativistic charge up in the internal charging and some low-energy electron charge up in the surface charging. They're both minor, and you can see the location there. Oceania for the internal charging, central Mexico, rather, and the Central Pacific for surface charging. Here's the 1-year chart of the relativistic electrons. That's from Solon.info as well. We saw a little dip here recently. And there's the 3-day chart. And we made it into warning levels again yesterday, not nearly as high as the 11 times level on August 29th. And it looks like a small downtick here in the electron flux once again. Here's the forecast model. And NOAA calling for similar levels. I would say they're going to be a little bit lower, maybe down here. That's my best guess, knowing a bit about the plasma physics. Next, we're going to show you the relativistic electron, the total electron content forecast. First, a diagram of the Van Allen belts. Feel free to pause the video if you're not familiar with altitudes and distances in miles. Here's a total electron content forecast, and things are looking pretty normal here. This shows you the entire electron density all the way up to a geosynchronous satellite, which orbit at tens of thousands of miles of altitude. Things looking mostly normal there. We're also going to show you the ionosphere. So this is only around the 300-kilometer level, where the F is located here on this little visualization. And it is not loading today. Let's see if we can get it loaded. All right, so for some reason we can show you the ionosphere map today, but not the anomaly map. So you'll have to just take my word on it when I say there are pretty minor anomalies here on the high-frequency side, the sun-facing portion of the planet. And what the ionosphere map shows us is essentially the pressure. And what you're seeing here is vibrational frequency. So let's try that again. What you're seeing is vibrational frequency, and I can't show you the latest image because it will not load today. We also can't show you the anomaly map. Sorry, there's the data. Ionosphere not looking particularly anomalously today. Continuing on. To go on to bonus features. So here we go. Here's the latest refresh of the intensity gram. We'll look up here first to see if there's a new sunspot rising, and indeed there's not. We don't see any umbre there at the moment. That is just an active region known as a plage. Sunspot 2859 still degrading here. Now alpha class. Sunspot 2860 still quite large and quite likely to produce significant solar flares. That's why we have a solar flare warning and a coronal mass ejection watch in place. Anyway, there's that active region. Again, no umbre. And there's Sunspot 2860, the most interesting solar feature in the past couple of weeks. Here's some ground-based Solar data from El Teide, Spain. And this is only like 3 minutes old from when we made the video. All eyes on this area here. You can see some filaments down here. Not that many filaments on the Earth-facing portion of the solar disk. Speaking of the solar disk, here's a full view of it. This is ionized helium, 304 angstroms from the Solar Dynamics Observatory. This coronal hole over here is so well defined it even shows up in ionized helium frequencies. It's a significant one. And it could send some high-speed wind our way. We'll be keeping an eye on that. Here's the full disk in 171 angstroms, my personal favorite wavelength. We'll be monitoring that active region in the northeast as well today. How about some more close-ups of Sunspot 2860? What do you say? Leave us a comment. Let us know what you think of Sunspot 2860. If you're a new viewer, make sure you press subscribe. If you're on social media, if you haven't deleted your Facebook yet, press share. Share on Facebook. Tell Mark Zuckerberg about our channel, as it's in everybody's best interest to know about coronal mass ejections before they occur. It's why we forecast them. Something we didn't plan to do, we realized we are doing it, and so we do it. Yowzers. And we'll close things out here at 171 angstroms. It looks like some activity actually kicking up there at the end of the video. Maybe a flare happening once again while we record the video. It's become a regular thing on the channel, and for that, we thank you. In any case, remember to stare at the sun. Use our channel to do so. We've got the most spectacular imagery on the entire internet. And may that solar wind be at your back. Opinions expressed in this video are not necessarily the opinions of Smash News Network. Least busted, name and news.